around. I hope you're doing well.
Hey.
Boys, what do you have for me today?
Oh.
What do you got, Jesse?
It's my turn.
I said boys, but you can take.
I think you should say men, gentlemen, sirs.
Men not killed by Kuklinski.
Don't put that voodoo on me, Bobby. Don't do that. So today I bring to you interesting news. So a new study recently discovered what happens when your brain has an aha moment. We all have those moments where something we suddenly understand happens to us and we're like, oh yeah. Well, when you have an aha moment, your brain physically changes how it processes information, making these insights about twice as memorable as gradual learning information. So, basically what they did for this study is Duke and the University of Berlin ran a test where they put a bunch of people into MRI machines and had them look at things, like little brain puzzles. This is one example. I'll just link it to you guys. I wish I could show you the one before you see what it actually is, but for the sake of audio listeners, it is a black and white photo of an outline kind of a snake.
Oh, I see. Okay, so yeah, it's kind of hard to make out what it is if you don't have the other image for context.
Right. And
Gotcha.
so they scanned the brains, and everyone who was looking at images similar to this, right, as they were trying to figure it out, if you gradually figured out the image, it registered. But if you had an aha, like, oh, I know what that is, it registered. So then, several weeks later, they bring everyone back in, put them in the MRIs, and they ask them about these things and what they remember. And anyone who had an aha moment for an image remembered that image twice as much as those who just gradually figured it out over time. And so that was like the big, it turns out that having aha moments really is the key to learning. That slowly learning stuff over time doesn't necessarily stick with you in the same way as, I think it would translate to whenever you have something really amazing happen to you, like a reward for doing something, or a betrayal of some sort, or a heartbreak, whatever the case may be. That is a lesson you learn, like putting your hand on fire. That's your aha moment.
Yeah.
Do that again. And the same thing here is when it comes to learning, that's kind of the way it works. So during insight moments, your brain's visual processing areas work more closely with emotional and memory centers, creating a unified network that strengthens memory formation. The research suggests that learning through discovery and insight might actually be more effective for long-term retention. And so that should be a way that we learn to teach people is like, hey, you know what? Maybe it's better than just like, let's take notes. Like getting people to actually do stuff and learning from that is huge.
That makes sense. It's the way I learn. Like I need to do something. I need to understand it, see it in front of me before it clicks. If I have to take notes, the only thing I was ever good at was history, but everything else, God, makes sense. It makes sense, honestly.
Yeah,
it really does.
Yeah. And that's what I bring to you.
Well, what about you, Alex?
A delightful scientific revelation. This is also sort of a scientific revelation, This is from Coast to Coast, and it's about a Russian professor who thinks he may have solved the Dyatlov Pass.
Oh, okay.
So he says that it may have been caused by a rocket launch gone wrong. If you don't remember, this is one of the earliest episodes we did on the show. 1959 case, 9 hikers died in the Ural Mountains. Everybody talks about it. They think, they took off their clothes. They went crazy. Maybe something happened. There's all these radiation, alien type stories, all this stuff. But apparently, it was a rocket mishap that was covered up, according to this professor who apparently was almost in it. So he was a friend of Igor Dyatlov, this guy, Peter Bartolome. So he was a late scratch. He became the doctor of technical sciences at the Ural Federal University. And as a result of being a near miss on that expedition for all these years, he kind of has had it on his mind. And he had a press conference last week where he actually presented his idea that it was a rocket to other researchers. And he said, quote, the preservation of the group's footprints over a vast distance indicated nitrogen acid exposure in the environment, which is like one of the big things. He says that's one of the only correct scientific explanations. And he says that maybe it was a rocket that experienced emergency flight interruption that was launched that night from a Soviet military base about 1,000 miles away from the pass. He said that
like an unmanned rocket.
What?
An unmanned rocket, I'm guessing.
Yes, like a weapon, like a
missile, not like a rocket to space.
Yeah. He posited that there was high-ranking government officials at the campsite after they found the bodies, which would indicate that they knew that there was something sort of like high profile about what was going on that needed to be covered up. And apparently he's not the first person to say this. Apparently there's a press conference in 2023 where a bunch of other Russian scientists also came forward and made the case that it was a rocket that, like having to do with the idea of the nitric acid fog enveloping the scene, the footprints, et cetera, et cetera. And, so that's like the basic way that they assert it. And you can actually, like, if you want to like follow a link to like a slightly older article about this with the exact same art, there's an old article from Coast to Coast that you can look at about that from a couple years ago. But people who disagree with this say that this would be something that when the rocket takes off that would be dissipated or used up, that there wouldn't be enough of it for this to occur in that area, or something like that. And so the hikers never got hit by that. So I don't know. I don't know what the vibe is. There's a lot more to this, obviously. Like, I bet you if I
don't even
spoke
think that was
Russian,
a theory when we did it.
No, it definitely was not. If I spoke Russian, there's actually a like Euronews like website about this story also, and he's talking about the rocket was launched from Kapustin Yar on February 2nd. It had an emergency abort. There was Leonid Urakov in Sverdlovsk who showed up. Like, so yeah, the Russian article just seems to have more specifics about who it was and has pictures of people and things. But it does seem like a legit possibility that that's what this was like a news story from, Russian mid-century that was like one of the famous cover-ups that has like become a meme and is now maybe slowly going to be revealed to be something other than what we've kind of believed it to be for many years, which is interesting. It's interesting to get a like mundane explanation, even though it's kind of still an intriguing one. Yeah, for something that we've wondered about for so long.
There were still a few mundane ones too when we were talking about it before. Look, that's episode 11 we did, so that might be a future revisit one day, a deeper dive. Dyatlov Pass again,
big time. But I just think that's interesting, and
it is.
I wonder if like what effect that will have on like the literature and like, remember that game like Holat or whatever that game's called, and like there's a couple other games that were like based off the Dyatlov Pass and the mystery of it, and then it's just going to be explained like, oh, like a rocket came over there.
Yeah,
I don't know.
And that's usually what the explanations usually are, right? Something more simple than mystical.
Interesting.
Well, I got a science breakthrough that dropped today, gentlemen.
I love when that happens.
About 10 hours ago. For the first time, a single atom acts as a quantum computer and simulates molecules.
What?
So I'm going to go through this and explain the best I can, okay? Because I've been trying to do some research on it. So basically what has happened is a single atom has performed the first full quantum simulations of how certain molecules react to light. The researchers who carried out the feat say that their minimalistic approach could dramatically speed the path toward a quantum advantage when quantum computers will be able to predict the behavior of chemicals or materials in ways that are beyond the reach of ordinary computers. Quote, the key advantage of this approach is that it is incredibly hardware efficient. This is Ting Ray Tan, an experimental quantum physicist at the University of Sydney. The single atom can encode the information that is normally spread across a dozen or so quantum bits, which is the quantum particle, the computational units used in most quantum computers. The findings were published on the 14th of May in the Journal of the American Chemical Society. No quantum computer had simulated this level of complexity in the energy level of molecules before. A computational chemist has at the University of Toronto in Canada said that this is a tour de force that will remain in the history books. So basically what they were able to do is researchers were able to encode different parameters, information, or what have you, into a single ion that they trapped in a vacuum and began pulsating through lasers like electric fields to excite the molecule's electrons to try and correspond to similar excitations in one of the ion's electrons. So let me see if I can get this in a way that makes more sense. Somebody on Reddit was trying to break this down. So what they were saying is basically, let's go, there's the top of the comment. So normally to simulate a molecule, especially when it behaves when light hits it, apparently you need to model all its electrons and atoms and how they move over time. This is super complex because quantum mechanics doesn't give you one path of motion, it gives you a spread of possibilities. So the trick they're using is rather than modeling the molecule directly with a giant supercomputer and lots of qubits, the researchers used a single trapped ion to stand in for the behavior of a molecule's electrons.
Whoa.
Basically, they were saying the atom is a molecule. They were saying instead, we can make this atom behave in a mathematically equivalent way to how a molecule's electrons would behave when hit by light. Basically, it's a clever proxy is what they're saying. The trick that they're using is molecules react to light by having their electrons jumped around. So they get excited into new energy states, vibrating, changing their relationships with each other. That's what chemistry is. What the researchers did was craft a very specific, finely tuned laser pulse to interact with their single atom in a way that imitates those same electronic changes. They say, think of it like choreographing a dance. You train one dancer, the atom, to perform moves that step for step represent the full dance of an entire group of dancers, the electrons in the molecule. The
That
atom
just
isn't
doesn't
doing
seem
this-
like it should be able to work.
The atom isn't doing the same thing physically. It's doing a mathematical equivalent,
Right.
which is what you need to simulate in chemistry. Molecules like allene, butyrene, and pyrazine was what they chose to simulate. And then they said, normally, to simulate a molecule on a quantum computer, you translate the molecule into Hamiltonian math, break it into qubits, use a ton of quantum gates and entanglement operations to evolve the system over time, run many repeated trials with lots of error correction, and finally stitch the data together. What the researchers said was, what if we just encode the entire problem directly into the laser pulse itself? Instead of building a massive quantum circuit, they shaped a laser to precisely mimic how the molecule's wave functions evolve over time. They said this is kind of like skipping the whole movie studio and just projecting a final film onto a screen. They're directly injecting a direct injection of the simulation into physical reality without having to simulate each frame step by step. The laser pulse was pre-computed using classical methods, and the pulse was designed to make the atom play out the evolution in real time. It's not computing the solution, it is the solution. The researchers set up the atom with the right initial conditions, fired the laser pulse, and watched the atom's quantum state change over time, tracking the energy levels and behavior like a molecular kind of like reaction movie. Each moment of that evolution corresponds to a step in how a molecule would respond to light, how its electron shifts, how it vibrates, and how it might eventually break bonds or form new ones. They recorded the data from the atom and then reconstructed the equivalent behavior of the molecule. So basically, in effect, they converted complex chemistry into like a weird program laser for a single atom, and then they could watch it do what it was supposed to do. Basically, this says they were able to simulate quantum chemical dynamics using 1 million times fewer resources than usual. The equivalent is like running Photoshop on a pocket calculator.
Where are our science people? Because I feel like I need
to meet.
I need a breakdown that makes sense. Because I'm with Alex.
try.
Like it doesn't seem.
It seems impossible.
I don't understand.
Do you remember last when we talked about the atoms connecting and acting
I remember.
the same?
And then I said I don't understand.
So
I also said I don't know what this means.
I tried to, I explained it best I can. Then the science people that I mentioned like went through the article, talked to them on Discord, and they were basically like, no, you basically have it. They're basically, these atoms, instead of, they're looping, they're coming together and still operating as both a wave and a particle at the same time. So like, and that shouldn't be capable, but it's happening. So they're using a single atom to cause it to react as though it were certain reactions as opposed to running simulations. It doesn't, it sounds like it shouldn't be possible, but that's like the weird shit about quantum mechanics is like, There's a reason there is no logical connection between quantum physics and classical physics. We don't know where quantum physics stops and classical physics begin. There is no math that connects them. That's what makes them so disparate, because no one knows how they connect. So that's why quantum science is so weird, because at what point does it collapse and choose a state? Because initially the idea was when something collapses, anytime it is measured, but measurement is simply an interaction with another atom or whatever. But then the study we talked about last week was all these other atoms coming together and then unifying and then acting like a wave and a particle at the same time and not decohering and choosing a state.
It's just like, that simple.
Yeah, oh yeah, just that simple.
It's
so like,
just that simple.
I don't know, man. Yeah, science people, please explain this. It's like all over different webs, like science websites. I'm trying to like wrap my head around it, but as always, I feel like I just can't. It's bizarre.
Absolutely wild style.
And that is where I'm going to leave your blown minds.
God bless you.
Quantum science. It keeps getting crazier and crazier.
I have a headache. Guys. I have a headache trying to think about that. I literally like froze like a computer and like tried to comprehend that for 5 minutes.
Yeah. Good luck. It's impossible. We'll be back next week, everybody. Thank you so much for supporting us here at patreon.com/Chilluminati pod. We appreciate you. We
love you guys.
Goodbye.
Bye.
Bye.